Now, my dear student, from our equation number 45 for our first topic, it can be written as this one. Kwa equation yetu tutaweza kuiexpress as we observe here that I must be equals to m1 r square we add by m2 r square we add by m3 r square, then we add by mnc times it r square. But we observe that the radius is the same. We have the same radius, we have the same distance for those ring, for those small ring having the same distance. Now we were supposed to factor out the r. Kwa tunataka tuweze kufactor out r as we observe here. So if we factor out the moment of inertia should be equals to bracket m1 plus m2 plus m3 plus dash dash plus ms times then times the r square. This must be equals to this one. But we know that m1, this is summation of the mass, the sum of the mass for the small ring of the whole must be equals to the individual masses of the ring. So instead of writing this summation, we are supposed to put this value which is called the largest m, which represents the mass of the whole ring. This is how we express it, my lovely students. So if we substitute equals to m, now we should say that I must be equal to mr square. But we know that m represents the mass of the ring, while this r square represents the radius square. It means it represents the radius square, the radius of the whole ring, while I represent the moment of inertia. Now we can say that the moment of inertia for the ring must be for the hollow cylinder must be equals to mr square, where m1 plus m2 plus m3 plus n terms of m must be equals to m. Kwa yule m1 wale summation of their masses for the small ring must be represented equals by the larger m ambana tunamuhesabu ni kama mass of the hollow cylinder. So which the mass of the hollow cylinder, this should be the mass of the hollow cylinder. M kubwa ata represent ni mass of the hollow cylinder ambao ni sawasawa na summation of their masses for the small ring that are found inside the hollow cylinder. So therefore, the total moment of inertia of the hollow cylinder about an axis through its center is given by this one. So at the moment of inertia here, the total moment of inertia of the hollow cylinder about an axis through its center should be given by this one. Kwa tutakonclude kwa kumwambia kumbe sasa yule moment of inertia ya yule hollow cylinder, it means the moment of inertia wa hollow cylinder about an axis atakuwa atabini expressed as I is equal to mr square, where I represent the moment of inertia for the hollow cylinder, while m represents the mass of the hollow cylinder, and also r represents the radius of the hollow cylinder. So this should be the question number 47. It should be the question number 47 for our first topic. So after this one, now we are supposed to note by saying that the formula of the moment of inertia of the hollow cylinder about an axis through its center equation number 4.7 here, as we tried to see. Equation number 47 through the center equation here is similar with the ring. So here we should conclude by saying that the moment of inertia which we tried to obtain through the equation, we tried to demonstrate at the equation number 47 for our first topic, must be is similar with the moment of inertia for that of the ring. This expression as we tried, kwamba tulijaribu kudemonstrate kwenye ring kule, tukaitemu ni equation number 24 for our first topic. Tukasema moment of inertia ya ring ni sawasawa na mr square. If it is equal to mr square, now we should say that this formula is the same with that of is the same with that of is the same with that of the hollow cylinder. Kwa tutasema sasa hizi zote zinakuwa na the same formula, my dear students. So after this one, now suppose the solid and the hollow cylinder have the same masses and radius. Now let us go and see that imagine if we have the solid cylinder and also the hollow cylinder and having the same mass and radius, then the ratio here of the moment of inertia of the solid cylinder, ambayo ni question number 44 Romani 44 for our first topic, to that of the hollow cylinder equation can be given at this one. We are going to see the relationship between the moment of inertia for the hollow cylinder and also for the solid cylinder, because all of these are the cylinder, but it can be categorized into there are several meaning. Now we are going to see how they can be related. That is what we are going to observe here. So we should, if they have the same masses, and also radius, now we should take the formula of the moment of inertia for the solid cylinder and divide it by the moment of inertia for the moment of inertia for the hollow cylinder. Now we should obtain it by saying that the moment of inertia for the solid cylinder must be equals to the moment of inertia to the half time the moment of inertia for the hollow cylinder. So as we observe and conclude by saying that now the moment of inertia for the solid is less than the moment of inertia for the hollow. Kwa hiyo moment of inertia wa solid huyu atakuwa ni mdogo kama tunapoona, kwa sababu atakuwa ni nusu ya ule moment of inertia of the hollow. Kwa hiyo ile moment of inertia wa hollow atakuwa ni mkubwa kuliko moment of inertia for the solid. Now from the definition of the moment of inertia, this implies that so the cylinder rotates much easier than the hollow one. Kwa hapa tutaweza conclude sasa kutokea kwenye definition, we should conclude by saying that we should conclude by using the definition that solid cylinder rotate much. We know that the solid cylinder must rotate much easier than the hollow cylinder. Kwa ile kwa sababu ina masi ndogo, kama itakuwa na masi ndogo, basi itakuwa na uwezo wa kuzunguka kwa haraka zaidi ukilinganisha na ile hollow cylinder. Kuna maswali ambayo yanakuwa yanakuuliza kwamba sasa kwamba elezea if we have the same if we have the hollow cylinder and also the solid cylinder, which cylinder should rotate very faster compared with the other one. Kwa hiyo nataka uweze conclude kumwambia kwamba ile ambayo itakuwa na uwezo wa kurotate faster than au easy kwa haraka zaidi kuliko nyingine ni hii solid cylinder. Kwa nini tunasema kabisa kwamba hii solid cylinder itakuwa na uwezo wa kuzunguka kwa haraka sana ukilinganisha na hollow cylinder? Tutamwambia reason yake ni kwamba this is because mass distribution in solid cylinder is closer to the axis of rotation than in the hollow cylinder. The answer is that this the solid cylinder should rotate very faster compared with the hollow cylinder because because of their mass distribution. So the mass distribution for the solid cylinder is closer than the mass is closer to the axis is closer to the axis of rotation compared with that of the hollow cylinder. Ndio maana inakuwa na uwezo wa kuzunguka kwa haraka zaidi kwa sababu yenyewe ipo karibu na ile axis of rotation. So my dear student, here there are some tasks I should be asked. You will be asked to demonstrate to prove that the moment of inertia for the hollow cylinder equals to mr square. And also you will be asked to explain that why this moment of inertia of the solid cylinder rotate faster compared with that of the hollow cylinder. this is some task you will be asked from this session. So by saying that this is the end of our session here, now I would like to welcome you again for another session. I wish you all the best. Have a nice moment.